Quadratic equations have a lot of practical relevance. Here's an example of how quadratics can be used to solve a problem in a very real situation. If we've got a rectangle that has got a perimeter, that's the distance right around, of 24 centimeters, we've got to build a table of information using this information. So let's assume that the length could vary from 1 up to 11 centimeters. Now, we've selected 1 to 11 because if you had 12 centimeters, well, you'd have 12 and 12 on that side. That'd use up the full perimeter without using any sides. So you can't go any more than 11, and of course, you can't have a distance if you're using whole numbers of less than 1, that would be 0. So if that's the length, then if you think about it, if that's got a length of 1 and a length of 1, then that's 2 altogether. Take that away from 24, that would be 22. That would mean that that distance there would have to be 11, and that distance there 11 as well, because you've got 11, and 11 is 22, 23, 24, and there's our distance. So the breadth could have a distance there of 11. If this was 2, so if we change that to a distance this way of 2, and this one here of a distance of 2 as well, that would be 4. That would leave us with 20 altogether, which would make this distance here a maximum of 10. So that would give us a breadth possibility of 10. And if you keep doing this and adding the 3 and the 3, that's the 6, taking it off 24 to see what's left, then you'll end up with a perimeter going down like this of 9, and then 8 goes down in a nice even way. 7, 6, 5, 4, 3, 2, and 1. So to do this mathematically, if we said that the perimeter is equal to 2 times the length plus 2 times the breadth, then if you had if you just put in your values to work out what you'd get, you'd find that an example would be that 2L, that's twice the length plus twice the breadth, would equal 24. And if you then, this is sort of like a little bit of algebra, you can actually factorize this. What it means, and we'll show you how to do this later, you can actually take the 2 out of this side because it's common. And when you simplify this equation, I'm just showing you how to do it. Later on, we'll actually look at the method behind it. That's 24 divided by 2. That's equal to 12. So what you've got is that the length plus the breadth must equal 12. And that's why 1 plus 11 equals 12. 2 plus 10 equals 12. 3 plus 9 equals 12. It's just a mathematical pattern, but as long as you can understand how it came about by looking at the first diagram, I think you'll be right. However, the important thing is here, you've got possible combinations. You could have a perimeter, a rectangle with a length of 1 and a breadth of 11, or a length of 2 and a breadth of 10. These are all the possibilities. Here's one, a length of 9 and a breadth or a width of 3. And each one of these will give a different area. You have a look at this. Remember, area is calculated by taking the length times the breadth of a rectangle. So length times breadth is area. So I'll write this over here. The area is the length times the breadth. So 1 times 11, 2 10s, 3 9s. Notice the area is changing. Now all of these perimeters have got the same total of 24, but the area changes. This is 32. This is 35. This is 36, and then you'll find something very interesting happens. Starts to go down again. 35, 32, 27, 20, and 11. So what we're going to do now is, after we've completed this, we're actually going to draw the graph of this to see what it looks like. And this will be a parabola. So we need to label the length here and the area here. We're actually going to compare the length of the side to the area in total. That's what it's going to be. So let's mark on a few things. We might make this, now we've got to go up a maximum of 11. So if we go 2, 4, 6, 8, yes, if we go up like in twos, 2, 4, 6, 8. Now it'll probably go off the page here, but that's okay for now. That's 10. We'll get the idea. And if we go up, let's say in tens here, 10, 20, 30, 40. We don't need to go any more than 40. We can start to plot this. Now this will be the area, so this will be in square units. Let's say centimetres squared, and this will just be distances in centimetres. So we know that L can't be 13 or 10 because, well, it could be 10, I guess, because if the length was 10, the breadth would be 2. Lengthwise, could it be 13? No, because if it was 13, 2 lots of 13 is 26. So we need only a length, a whole perimeter of 24. So yeah, let's plot this, and we'll answer those questions in a little more detail later. So let's mark them in, and you've got, when it's 1, we go up to 11, about there. When it's 2, we go up to 20. When it's 3, we go up to 27. So that's 25, 26, something like that. When it's 4, we go up to 32. So that's 35. So 32 maybe about here. We're up to 5 now, aren't we? 5, we go up to 35. So that's right there. 6 goes up a little bit more, 1 more to that. Then it starts to come down. And you'll notice that it comes down nice and symmetrical. And of course, if we had a number out here, it would be around about here. So if we plot these, or rather draw the line through them, and you have to do this freehand, I'll have to do this as best I can. So through the dots we go, like this. We end up with a parabola, an upside down parabola. So having a look at the other answers, can L be 13 or 10? Well, if we had L was 13, if L was equal to 13, then the breadth would have to be minus 1. The reason is 13 and 13 give you 26, and the breadth would have to be minus 1, which would be minus 2, so that the total actually equals 24. So it's impossible. That can't happen. So if L was equal to 0, now I think what was meant to happen here, could it be 0 here? And the answer, if it's 10, yes, but if it was 0, no, it couldn't be, because you can't have a length of 0. But what about finding the value of A when L is 3.5? What would happen then? Well, all we need to say then is, for this one, I'll just change the colour back again. If L was 3.5, then 2 lots of L, that would be the 2 lengths, would have to be 7. That would mean that the perimeter to be 24, if you took away 7 from 24, that would give you 18 centimetres. No, wait, on 17 centimetres, isn't it? Sorry, 17 centimetres. 17 centimetres, because 17 plus 7 is 24. 17 centimetres, and if you halved that, you could get the breadth, which would be right. Now, the breadth would have to be half of 17, so that would be 8.5 centimetres for the breadth. So if that was all correct, then the area would be, we'd obviously have to halve 17, wouldn't we? Because, oh no, so we've got a length of 3.5. So the area would be 3.5, that's the length, times the breadth, that's 8.5. And if we multiplied that, we would have an area of 29.75 centimetres squared. So yes, that can be worked out, and that's right. The main thing to remember though is that there is the maximum possible area you could have. In this case, it would be 36 centimetres squared, and that would happen when you've got a length of 6 and a breadth of 6. So when you've actually got a square. So that's a very important part of that, and I'll explain to you how in reality that would work. Now, if a farmer, for example, had 24 metres or whatever it might be of wiring and had to build a field, if he built the field 6 by 6, he would use up the 24 metres and he would have the maximum possible area in the field. So this is a way of finding out how you could use the same amount of wire, 24 metres, and make it into a rectangular field, and the combination of a square 6 by 6, and a square really is a rectangle in a sense, would give you the best possible size area inside. So that would be the best way to use the wires. Now, let's have a look at a couple of quick diagrams here. All you've got to do here is to graph these ones. So I'm actually going to start this process with you. These are drawn, and we just need to make sure that when we draw these, the XY axes, that we put enough information or enough space for them. So if we put in, let's say 2 and 4 and 6 here, because we've got to go along to 5. 1, 2, 3. Actually, we could go 5. What we might do, I was going to go in 2s, but you could easily fit in numbers 1, 2, 3, 4, and 5 here. And the other side is minus, so it's -1, -2, -3, -4, and -5. Sorry about the writing there, I'm not sure why that's doing that. And then we've got to plot up the axis here. So we need to go up to, let's see, what's the biggest number? 27, so say 30. So if I go up in 5s, 5, 10, 15, 20, yes, that'll work. So if I go up 5, 10, 15, 20, 25, 30, 35, we can then plot these points. So I'll quickly run through the plots now, and let's get them. -5 and 27, -5 and 27. You go ahead and plot these as well, and I'll do it at the same time. So -4 and 18, so that's somewhere 15, 16, 17, 18, around about there. -3 and 11. All right, so off we go. -2 and 6, somewhere around about there. -1 and 3, somewhere there. 0 and 2, didn't quite make it to the XY origin. 1 and 3. Oh, you'll notice it starts to go up again. Symmetrical. 2 and 6. 3 and 11. 4 and 18. And 5 and 27. And joining all those together, we get our parabola, which is just perfect. Try and get it through the lines if you can. And we can do the same for the other side. Once again, you just work ahead and then make sure you get your answers with mine. There's the XY axis, just change that colour. And we'll use the numbers from 1 to 5 again. I'll put minuses before all of these. There we go. And what have we got to go to this time? Up to 29. So we could actually use the same combination. There's 5, 10, 15, 20, 25 and 30. And we'll go and plot these points again. So we've got minus 5 and 29. Minus 5 and 29 is about here. And minus 4 and 20. Minus 3 and 13. Minus 2 and 8. Minus 1 and 5. 0 and 4. So this is actually up a little bit and spread out a little bit more by the look of things. 1 and 5. See, the symmetry starts to come back. 2 and 8. 3 and 13. 4 and 20. And 5 and 29. So there's our final graph. Also a parabola. They all have the same sort of characteristics. And we'll put arrows in indicating that it could go further. So there's a little bit of work on quadratics. Now you need to practice them and just see how they work and do some more real life examples to see that you understand how this process operates.